Dang, Toad, how many pieces of pizza you got on there?
You split my hair.
Jeez. Toady, stop hogging all the pizza. Dude, come on, I still want some. Dude, I'm hungry.
Man, no wonder why Jake on the O-line, he eats so dang much.
Dude, I know, his shirt's like a 5XL.
You talking about me?
Huh?
Just wait, I'm gonna get you guys back someday.
I didn't say nothing.
Dude, I don't understand calculus at all.
Dude, how don't you understand? Juggle With is such a great teacher. I always see you in there after school, man. You're always getting help.
I just don't know, man. I don't know how to do it.
Yeah? You understand?
No.
Come on, Toad, we need this. Let's go.
This is basic geometry, dude. This will be easy.
Are you kidding me? That's basic geometry! We learned that in the 10th grade! How you gonna pass the AP test if you can't even do that?
I'm tired. Can I be done yet?
No, you haven't worked out the pizza yet, fatty.
Dude, I've been on here forever.
Wait a second. Jake, you've been on there for 20 seconds. You ain't been on there that long. How you that tired already?
Dude, my stomach's full.
Well, you shouldn't have ate all that pizza then.
Oh, dude. Cookies and cream ice cream? Dude, you guys got the big container of it.
Toad, you just ate a whole pizza!
Alright, I'll put it back.
Come on, guys.
Toad, you coming?
I'm just gonna take the elevator.
Are you serious, dude?
Yeah, my legs are dead, man. I'm
It's
just
like
gonna
5
take the elevator.
stairs!
I'm sorry, dude. I'm just tired.
The old slicer football. I remember those good old days. Watching Toady out there, slowest one on the field.
I may be slow, but you're not gonna be fast enough to move out of...
Question 1. How do you calculate the displacement formula for the balloon?
We knew that the equation for displacement was going to be an exponential function. At 0.5 seconds, the balloon hit Trevor, who was standing 17 and 1/6 feet away. We then plugged those numbers into the equation. To solve for A, we took the natural log of both sides. We then whipped the 0.5 down and divided both sides by 0.5. Then we took the base E to cancel out the ln. We then solved for A and plugged it back into the equation. Our final equation for displacement is y equals 294.694 repeating raised to the x.
Question 2. How do you find the equation for instantaneous velocity? Now that we have our displacement formula, we can use that to find the derivative formula. To get the derivative formula, we simply take the original function times the natural log of b, which in this case is 294.6944 repeating. Now with the derivative formula on hand, we can solve any questions pertaining to instantaneous rate of change. Question 3. How fast was the water balloon moving at 0.3 seconds? Was it A, 24.301 feet per second, B, 31.305 feet per second, or C, 30.675 feet per second? Simply plug 0.3 into the equation for the variable x. The solution equals 31.305 feet per second, or B. Always finish with a sentence. Question 4. At what time is the balloon moving 24 feet per second? Start the problem off by plugging 24 in for y. Then divide the natural log of 294.6944 repeating over to the other side. Then take the natural log of both sides by simply whipping down the x on the right side. Next, divide the natural log of 294.6944 over to the left side to isolate the x. When you solve for x, you find that x equals 0.253 seconds. From this, we can conclude the balloon was moving 24 feet per second at 0.253 seconds from the release. Question 5. How do you find the tangent line equation at 0.25? First, you start off with the basic linearization equation, which is L of x equals f of c plus f prime of c times x minus c. Next, you plug 0.25 into the original equation. Then you plug 0.25 into the derivative equation. You get these corresponding answers for those problems. Now you can take the basic linearization equation and plug in your numbers. The final equation stands as L of x equals 4.143267 plus 23.558367 times x minus 0.25. When L of x is graphed alongside f of x, local linearity can be observed. Now we can use our L of x equation to approximate f of x values and then calculate the error for that approximation. Here we are trying to calculate the value at 0.27. We get our corresponding values for 0.27 for L of x and f of x. To calculate error, simply subtract your f of x value from your L of x value. The final error is 0.0278. Question 7. How do you find the distance the balloon traveled using Riemann sums? To do this, we want to use the most accurate version, which is the midpoint sum. Here's the basic outline, which says if f is integrable on AB, and if Rn is any Riemann sum for f on AB, then we can use this equation to find the integral. First, for our equation, we have to put in our upper and lower limits, which is 0 for 0 seconds and 0.5 for 0.5 seconds when the balloon hit Trevor. Then we plug in our f of x equation, which is as follows. Next, to find your triangle x value, simply subtract your upper limit from your lower limit and divide it by the number of rectangles you have, which gets us 0.1. Put your triangle x value out in front of the parentheses. Next, for the midpoint formula, you have to go halfway between your triangle x value. So you split 0 and 0.1 in our case and land on 0.05. You continually go up by that triangle x value until you've done all your rectangles. When solved, this midpoint formula gets us 15.95. You can check this number by going to our sum on your calculator. Plug in your corresponding upper and lower limits as shown. Then input the number of rectangles you want to solve for. Then choose what method you want to use, which in our case is the midpoint. The calculator will then show you your graph with the rectangles drawn in. And there is our corresponding sum, 15.9509. Question 8. How do you use the fundamental theorem of calculus to find the distance traveled? The basic formula states that if g of x equals the derivative of f of x, then the integral of that antiderivative equals g of b minus g of a. So, our basic setup is the exact same as it was the question before. This time though, we take the antiderivative, making sure to put our bar and our upper and lower limits to the right. Now to do the math, simply plug that antiderivative in the y1. Then take y1 of your upper limit minus y1 of your lower limit to get the answer. The answer is 16.1666 feet. To check this, first plug the derivative equation back into y1. Then go to math and down to 9. The first two inputs are always the same, which is y1, x. Third comes your lower limit, then last is your upper limit. When you solve for this, you get the exact same answer as calculated before. Question 9. How do you use Simpson's rule to calculate the distance traveled by the balloon? The basis of Simpson's rule is 1/3 of your triangle x value times your first y value plus 4 of your y1 plus 2 of your y2. And those 4's and 2's keep going back and forth until your last y value, which is just that value. To use this formula, we will need a table of values, shown here. So, we plug in our 0.1 for the triangle x and then just plug in the numbers right off the table. Plugging this into the calculator, we get our answer to be 15.4095. This answer will be labeled in feet, of course.